Hello, geometry students. Mr. Zacek back, and better than ever, we're rolling through Unit 10. We are in Lesson 4, and we're going to look at the perimeter and areas of similar figures. So when we think about similar figures, we're thinking about a couple of ideas that, number one is corresponding angles are congruent. Number two is that sides are proportional. And that's kind of the piece that we're going to look at here with this. Now, we've got a couple notes here. Is that if the scale factor of two similar figures is a to b, the ratio of their perimeters is a to b, and the ratio of their areas is a squared to b squared. Let me give you an example that can help illustrate this. Let's take a square, and it has a side length of 1. Okay, well, the perimeter of that square would be 4, and the area of that square would be 1, because the area for a square is base times height, which is 1 to 1. Let's say we take that square and we multiply the sides by 3. So now the sides are all 3. Well, what is the perimeter of this new square? Well, 3 plus 3 plus 3 plus 3 is 12. And the area is 9. So here's what I want to point out. We multiplied the side by 3. What happened to the perimeter? Well, to go from 4 to 12 is the same as multiplying by 3. But what happened to the area? Well, we went from 1 to 9. What's 3 squared? 9. So that is the ratio of the area gets squared. So as we look at this question, number one, the trapezoids are similar. The ratio of the lengths of corresponding sides is 6 to 9, or we reduce this. We always want to reduce these. 6 to 9 reduces to be 2 to 3. Okay, that would be what we would consider. This is called the scale factor. Scale factor you always want to do in the simplest form. So what is the ratio, smaller to larger, of their perimeters? Well, that would be 2/3. What is the ratio of the area? Well, we simply take the perimeter and we square it. So 2 squared over 3 squared, which would equal 4 over 9. Okay. So one of the ways you can think about this is if we have perimeter and then we have area. If the perimeter is a to b, the area is a squared to b squared. So to go there, you have to square it. To go from here to here, you have to take the square root. Okay, so two similar polygons have corresponding sides in the ratio of 5 to 7. That is simplest form. So what is the ratio of their perimeters? Well, it would be 5 to 7. Okay, again, this 5 to 7 is what we consider the scale factor. And then what is the ratio of their areas? Well, it would be 5 squared to 7 squared, or 25 to 49. Okay, now we're going to do a little bit of a different question here in number 3. The area of the smaller regular pentagon is approximately 27.5 centimeters squared. To the nearest tenth of a square centimeter, what is the approximate area for the larger pentagon? Okay, so let me walk you through this question. We need to first determine the scale factor. And so as we look at the two sides we're given, we have 4 over 10. So we're going to reduce that down to be 2 to 5. 4 over 10 reduces to be 2 to 5. So now what I want to do is the scale factor, this is our A over B. Right? This is A over B. Now I need the area ratio. So the area ratio is going to be a squared over b squared. So for this example, it would be 2 squared over 5 squared, which would equal 4 over 25. All right, now the next step in this is we want to create a proportion. So in the proportion, what we're going to do is we're going to set the ratio equal to the actual. So the area, or more specifically, the area ratio equal to the actual areas. Remember, a proportion is two fractions that are equal. So the area ratio is 4 over 25. Now we got to go back into our question, read the first sentence. The area of the smaller is this. So we're going to match it up in the numerator. We'd put 27.5 in the numerator, and we put x in the denominator, and x will be for us the area of the larger one. So we use our cross product property. 4x equals, what's that, 25 times 27.5. So 25 times 27.5, excuse me, then we're going to divide that number by 4, 171.875. Okay, so what was that? 687.5. Okay, so 687.5 divide by 4, and it would be 171.875. So 171.875 in its area to the nearest tenth, so we would say 171.9 square centimeters. All right, so the idea here, just to again follow you through the steps, is 1, we determine the scale factor, 2, we determined the ratio, 3, we set up a proportion to find the actual. All right, so here we go again. The scale factor of two similar parallelograms is 3 to 4. The actual, the area of the larger is 96. What is the area of the smaller? So again, let's just kind of walk through those steps. So the scale factor, we already know that, is 3/4. So now we need the area ratio. Okay, the area ratio is going to be 3 squared over 4 squared, which would be 9 over 16. And then step 3 is to set up our proportion. So the proportion is going to be the ratio, and then the actual, now we know the larger is 96, so we'll put that in the denominator, and then x will be the area for the smaller. So 16x equals, what's 9 times 96? 9 times 96 is 864. Okay, and then we divide that by 16. So 864 divided by 16 is 54. Okay, so 54 square inches. All right, and that number is definitely smaller than 96, so it meets that part of the condition for it. All right, so moving on here. During the summer, a group of high school students cultivated a plot of city land and harvested 13 bushels of vegetables that they donated to a food pantry. Next summer, the city will let them use a larger, similar plot of land. In the new plot, each dimension is 2.5 times the corresponding dimension of the original plot. Okay, how many bushels can the students expect to harvest the next year? Okay, so this one's a little bit, we got to think about kind of the multiplier. So what we're doing is we're multiplying the dimension, so the dimension multiplier here is 2.5. This kind of goes back to our square example that I did at the very beginning. So therefore the area multiplier, here's another way we can kind of think about this concept, is that's going to be 2.5 squared. So the area multiplier, 2.5, I think I didn't get the point, 0.5 squared is 6.25. Okay, so 6.25. So if we take our output, or the harvested 13, and we multiply it by times 6.25, that will give us the number of bushels that we could expect. So take that number, multiply it by 13, so 81.25 bushels. So it has a pretty, that 2.5 for the dimensions really affects the area very significantly. So we don't just multiply it 2 by 2.5, we got to multiply it by 2.5 squared. All right, in the diagram below, triangle ABC is similar to triangle DEC. If AC is 12, DC is 7, and DE is 5, and the perimeter of ABC is 30, what is the perimeter of DEC? So what we want to see here is we want to start off by kind of determining the scale factor. And we can determine the scale factor by comparing two sides. So if I take AC over DC, that would be 12 over 7. That's our scale factor. So therefore, the perimeter ratio, this is kind of our 1, 2, 3 process again, scale factor ratio would also be 12 over 7. It isn't any different. And now we're going to create then a proportion. So we take our ratio and then we set it equal to the actual. Well, we know the actual perimeter of ABC, that's the larger triangle, so we're going to put that in the numerator, and we'll put this in the denominator. So we solve 12x equals 7 times 30 is 210, and then 210 divided by 12 is 35 halves, or 17.5. So 17.5 would be the perimeter. So the perimeter of triangle DEC would be 17.5. All right, now last one. The perimeters the triangles are similar, okay? And we know the ratio of the areas. So we have the area ratio, which we can think of as a squared to b squared. So 50 over 98. Here's the key to this one. Let's reduce that first. So if we put a fraction tool here, 50 over 98 reduces to be 25 to 49. We didn't change the value of that at all. We just simply reduced it. Okay, that's the area ratio. Now we want to get to the scale factor, so how do we go from a squared to a? Well, we have to take the square root. How do we go from b squared to b? We take the square root. So, so the scale factor then will be the square root of 25 over the square root of 49, which is 5 to 7. Okay, so that one, we're given the areas, we have to simplify. This is the key step here. Okay, simplify first, and then we could take the square root to find the scale factor. Alrighty, so there you have it, and got some assignments here with this stuff just to help you kind of solidify these ideas. And let's ask and keep on asking questions. I'll see you back here soon.